Very good morning, everyone. This is Dhanvan Tuna from VIT Chennai. I'm here to talk about Caption Final Year project. I have done the project which is titled as Multi-Modal Analysis of Means under the guidance of Dr. R. Rajalakshmi. Starting with introduction, uh, so we can actually analyze first of all, like what are we working on? We are working on memes, and what is the reason behind working? So if you look around in the past 2 decades, there has been a growing trend of circulating of memes. Even if we look at ourselves, we spend most of the time, like the current generation, younger generation, and spending lots of time with memes, and so there are different owners, mostly humor, sarcastic, offensive, and many other. And what the main reason for the faster circulation of these memes in a very short span of time is because of its connectivity with the internet users, because it's mostly concentrated on related topics to students, politics, and sports, etc. There are advantages for the memes because it is easy to transfer news or any other particular content. But in the same way, there is also a dark side. We as the deep learning enthusiasts, I have decided that there should be an automatic meme checker where it can actually analyze the emotion which is carried out by a meme so that the hateful and offensive content won't be circulated. There is currently there are models which actually check if a particular tweet is having offensive content or not, and Twitter and other social media sites are able to restrict those tweets to circulate from other places. But when it comes to memes, it becomes a very hard method to actually analyze because right now, analyzing the uni model, which means that only tweets or only images, the state-of-the-art models have received a very high stage. But when it comes to memes, which are multimodal, which means that the memes contains both the images and text, it becomes hard. It becomes hard to analyze those memes. So our main objective in this project is to analyze such memes with the help of many multimodal methods which we have implemented in this project. Carried out in to build out the proposed methodology, we have carried out few of the related works which we consider as the baseline for our proposed methodology. In the first paper, they have analyzed on the means, but they considered only one emotion, which is hatefulness. The author was able to detect whether the particular meme is having hateful content or not. But but we do not want to limit to just one emotion. In the second paper, the author was able to consider four different states, which are humor, offensive, sarcasm, and motivation. In this paper, the author has analyzed these memes by unimodal analysis and multimodal analysis, and he's concluded that multimodal analysis on memes has given better results. In this third paper, the author has used a Memotion second version of the dataset, which consists of around 10,000 images, but the text was only limited to English language. And he also obtained a very high weighted F1 score of 0.8233. So, to the best of our knowledge, we observed that there are very few methods and few methods and works which are actually focused on memes. And in that particular context, there is only one or two methods which are current existing methods which are focused on analyzing memes with their OCR text in Hindi and English. So we are focused on this particular memes with their text in English and Hindi. So methodology is carried out by uh, methodology, what we have done is we have looked around a different range of data sets which are currently available in the internet, and we have found out that Memotion 3 dataset is one of the state-of-the-art dataset which consists of around 10,000 images, and we have used that particular dataset with the help, and we have used deep learning to actually extract the features from the image, and we have used TweetEval for extracting the text features from the text. Once those features are extracted, we concatenated them, and then we trained the model on the training set, and then with the best weights we have tested on test set. In this picture, we can actually have a picture or overview of the proposed methodology. If you see here in the right top, there is a meme which is given as Redditor visitors IG meme pages die from cringe. So so they have concluded. In the top right top, that particular image goes along with data processing, and then Emonet and EfficientNet B0. These are the two deep convolutional neural network we are considering for this project. So these the after the image goes through these networks, we get image features, and then these features are followed by global average polling and dropout function, so that there won't be any overfitting. Where when it comes to text side, the text is carried out with REST pre-processing, and then these text pre-processed will be converted into text embedding with the help of TweetEval, and after that it followed by LSTM, and then we concatenated with the image features, and then we have added few dense layers for the classifier part, and then we use sigmoid activation function. So yeah, so we have used, as I mentioned before, we have used Memotion 3, which is second version of the 20 Memotion dataset. It consists around 10,000 samples of memes, where 7,1,500 and 1,500 are the test, validation and train splitting. And then in this dataset, there are four emotions, which are humor, sarcasm, offensive, and motivation. So here you can observe that this is the clear distribution of the data sets, and you might actually have a doubt that each emotion is having 10,000. So what's happening here? So actually, our data set is multi-label data set. And one more thing you need to notice is that it is highly imbalanced. If you see here in the humor, the S is having around 6,000, whereas for no, it is having around 1,000 only. So the data set is very imbalanced, and we have taken in all the important precautions to actually have the appropriate results. This is the dataset preview. As I mentioned before, the dataset is the multi-label dataset. So if I first sample, you can see that humor, it is funny, sarcastic, it's sarcastic, motivational, not motivational, offensive, it's offensive. So it's if you convert into labels, it will be 1, 1, 0, 1. So this way, for each sample, you will have four labels with as the predictor. And yeah, so after the dataset review, we can go to the text pre-processing. Here, we observe that some of the memes actually have the text of usernames. So we believe that there won't be any dependence between relation between the username and the emotion lying behind the meme. So we have pre-processed those usernames into a user, so that model will predict in a better way. And also there are some unwanted URLs present in the text here. So we also replace those URLs with HTTP. And when it comes to image, so we are, as I already mentioned before, we have used Emonet and EfficientNet. So we are for the Emonet, the model is trained on grayscale images with the dimensions of 48 cross 48. So we have converted our the real samples into grayscale with the size and reshaped them into 48 cross 48, and then trained the models. So feature extraction. So how does this text feature extraction, and why do we need to do the text feature extraction? So the basically as computers, they do not understand the text. So we need to convert them into a form that it actually understands. So for that reason, we have used TweetEval, one of the state-of-the-art test embedding model, which was basically trained on Roboto database, which is a huge database compared to BERT, and it consists of many languages such as English, Hindi, Telugu, Tamil, Marathi, etc. So we have used that particular TweetEval model, so that since all our model, like our dataset, is also having English and Hindi, so we need to choose the perfect model. I mean, perfect test embedding model, which can actually which can actually be appropriate for Hindi text also. And when it comes to image feature extraction, obviously, as I mentioned before, since the machines won't be understanding text, it definitely won't be understanding images. For that reason, we have used EfficientNet and Emonet. I'll show you sample example for this. For example, just write number 2. So this is the image, but mission does not understand this. So what we do is, so this is consider this as the deep neural network. Okay, so this is the input image, and this is one of the convolution layer, convolution neural layer, and second CNN layer, third CNN layer, fourth CNN layer, and this is the flatten layer. Okay, so flatten layer, what it does is, so from all these CNN filters, it takes the input and it actually converts the two-dimensional image into one-dimensional data. So we use this layer as the input. So when it if you see here, this 2D image, like 2D image is nothing but 48 cross 48. Okay, but we are converting that 48 cross 48 into 7 into 512 cross 1. So now you're converting a two-dimensional vector into a single-dimensional vector. So these 512 and TweetEval gives output of 768. So these 768 and 512 combined, you get around 1380. So this was combined, and you will be using that as the input for the, and you will concatenate those two layers, and then you will be following up with uh, dense layers. So yeah, and in the also I need to mention clearly for efficient network. So the main reason for choosing efficient network was efficient network has come up with a new scaling method, which is known as compound scaling method. First of all, the main reason why I'm emphasizing on efficient network is I have also trained the dataset with the help of VGG19 and ResNet 50, but the results are completely insignificant when it compares to efficient network. So that's the reason I'm emphasizing on why what is the use of efficient net. So here in the compound scaling method, when it comes to, for example, take VGG19. What VGG19 does is, in the the deeper you go into, the filters will increase. So for example, in the starting you start with 32 filters. At the end, you will reach to 512. But when it comes to the compound scaling method, not only the filters increase, even the size of the dimension, like consider 48 cross 48, it might actually go to 70, like 212, 224 cross 224. So they have used this compound scaling method, and by wonders, it actually given a really great accuracies. And ImageNet dataset, which is the state-of-the-art dataset, consists of 1,000 classes. It has exceeded performances of ResNet, DenseNet, Inception, NASNet, and other state-of-the-art models. So as I already mentioned, so we are concatenating vision features, which are output of the EfficientNet and Emonet, with the TweetEval features, and then we are following that with uh, dense layers, and then we are using binary cross entropy loss function. The main reason why we are using binary cross entropy loss function is, as we remember, the data set is completely imbalanced. So we need to use a so we need to choose a proper loss function so that it won't overfit, or it won't train in a wrong way. So what the main reason for choosing binary cross entropy loss function is, whenever misclassification happens for a minority class, there will be a high penalty for those cases, so that it will train in both classes balancedly. And also for the performance metrics, we have observed that accuracy, MSE, which are basically, I mean, the best performance metrics whenever you try to evaluate a model, are not exactly fit for this particular data set, because once you observe the accuracy of any model for an imbalanced data set, you observe that, for example, there are 1,000 images. Sorry, there are 100 samples in a test, and if 95 samples belong to one class and 5 samples belong to other class, and still, if 98, it predicts for all the 100 as one, you obviously will be getting 95 as the accuracy. But that case, you're not actually giving proper results. I mean, proper penalty or real results for the native class. For that reason, we are using weighted F1 score. In this way, you will get unbiased result, and you will see the truth of the performance. So here we have chosen CNET, which is a baseline model, which is the only existing model available to which is actually tested on Memotion third version dataset. And model 1 is TweetEval plus Emonet. Model 2 is TweetEval plus EfficientNet. And we have observed that the model 2 has exceeded the performance of CNET in a significant way. Uh, so when it comes, overall, we observe that offensive and humor are the most challenging and easiest emotions to recognize in memes. In this bar graph, we can observe that in humor and offensive, the model 2 has actually given exceeded the performance of model 1 and CNET. And whereas for sarcasm and motivational, still CNET was able to perform a little better compared to EfficientNet and TweetEval. These are the overall average scores. So train here means that average of train of weighted F1 score of all the emotions, and it's clearly evident that our model 2, which is TweetEval plus TweetEval plus EfficientNet, has exceeded performance of CNET and model 1. So conclusion. Uh, we can conclude that we have chosen two different state-of-the-art models for the image feature extraction, which are Emonet and EfficientNet. The reason for choosing Emonet is it actually trained on faces, and we believe that faces has a significant part of checking whether there will be like a part of emotion recognition. That's the reason we have chosen Emonet. But with the results, we observed that emotions in memes can be more like they are insignificant when the faces in the memes is insignificant for predicting the emotion of that particular meme. And with the best results obtained from EfficientNet, we observed that the to recognize the emotion in memes, it's better to actually choose a model which actually able to detect all the other objects well. And the future scope, actually, here the future scope would be so the Memotion 3 dataset consists of only English and Hindi. So if we can actually provide other languages inside, like maybe Telugu, Tamil, and Marathi, etc., this can be easily adapted in throughout the country. So this could actually give a real-time application. And to also improve the data set, as 10,000 is pretty much a good enough data set, but when you add a few more languages, it would be very much significant if you can improve the size of the dataset too. And yeah, that's it from my side. Thanks for giving this opportunity. See you.